Hello class, welcome to this video on Chapter 7 practice test. So let's go over each of the questions. It's broken up more or less in order. So this is lesson 7.1, 7.1, then this is 7.2, 7.2, and then 7.3 and so on. It's more or less in order. All right, so number 1 says convert one measurement to another. All right, so we need to know conversions from inches to feet. So we'll do this over here. You're going to need to do this on another sheet of paper to show your work. All right, so 27 inches, we want to convert that to feet. So we need a conversion ratio, a conversion rate. And so we're going to put inches on the bottom so that we can cancel the inches here. And we want to, according to this, we want to convert that to feet. And there are 12 inches in 1 foot. So we're going to put 12 here and 1 foot. And so multiply this. This is just a fraction. So multiply it straight across. So 27 times 1. And then 1 times 12, so it's basically going to be 27 divided by 12 and feet. And then of course we do this on the calculator. We get 2.25 feet. All right, so now let's look at B. It says we're converting cups to pints, so 15 cups. All right, so we need to put cup here, so we can cancel out with cups there. And so we need our conversion ratio. We're going to convert from cups to pints. All right, so we want to convert to a pint. So there's 2 cups and 1 pint. And so the cups cancel, and we're left with pints. And remember, this is just an invisible 1 here, multiply straight across. So it's really just 15 over 2, or 15 divided by 2, which is 7.5 pints. Okay. All right, so now C, you're converting 37 millimeters to centimeters. Okay, so 37 millimeters equals, and blanks. Okay, so we're going to convert that to centimeters. All right, so if you go to you go to your conversion ratio, your conversion factors, we want millimeters on the bottom, we want meters here, and we're going to convert from millimeters to meter, and then from meter to centimeter. You can convert directly between millimeters and centimeters if you know how to work with the system, like work with the international system. However, I'm going to just show you the traditional way using the conversion factors. All right, so according to your conversion factors in your notes, we have that 1 millimeter is equal to 0.001 meters. Okay, and then we're going to convert from meters to centimeters. Okay, so we got meters here, centimeters here. So now meters has to be in the bottom to cancel out there. And according to the conversion, so 1 centimeter is 0.01 meters. Okay, so there you go. So remember, there's invisible 1 here, multiply straight across, we get 37 times 0.001 over, and then multiply straight across here. That's just going to be 0.01 and centimeters. Okay, multiply the top numbers and then divide by 0.01. So in that case, you're going to get 3.7 centimeters. All right. So now we're looking at D, 54 inches. We want to convert that to centimeters. Let me just use a traditional IN for centimeters, or for inches. And according to the conversion factor in your notes, first inches has to go on the bottom, centimeters on top, and it turns out for every 1 inch there are 2.54 centimeters. Okay, so that's the conversion factor. The inches cancels, and notice that you're just multiplying 54 times 2.54. So we'll just multiply those together. All right, so we'll do that here. 54 times 2.54. So we have 137.16. centimeters. All right, so that's conversion. So there's another conversion here. Number 2, the price of a beverage is $3.56 per liter. What is the price of this beverage in dollars per quart? So okay, so $3.56 per liter. All right, and we want to convert it to dollars per quart. So we need the conversion for liters to quarts, right? So if you go to your formula sheet or your conversion factors, we get that 1 liter is 1.06 quarts. Okay. All right. So we need liters to cancel. So put that on top to cancel out with the one on the bottom. So we need quarts down here. And we said it was 1 liter is 1.06 quarts. All right, so multiply straight across. So we just basically got 356 divided by 1.06. All right, see what that is. So that's we're rounded to the nearest cent, so 3.36, okay? So we got $3.36 per quart. All right, there you go. Let's look at number 3. Given that the measure of angle X is 150 degrees, find the measures of angles W, Y, and Z. Okay, all right, so now we know that angle W and angle Y have to be the same because they're vertical angles, and angle X and angle Z have to be the same because they're vertical angles. Vertical angles is when you have two lines cross and you're looking at the angles directly opposite of each other, that they don't share a side. Okay, so those are always going to be congruent or same measure, the same angle. So if this is 150, then this has to be 150 as well because of vertical angles. Okay, so the measure of angle Z is equal to 150 degrees. Again, it's because of vertical angles. All right, and then so now let's do angle W. Now angle X and angle W share a side. They share this side right here, and so therefore they must be a linear pair, or they must be adjacent, right? If they're adjacent and they form a straight angle, which they do, they form a straight angle, right? This angle right there. Then they add up to 180 degrees. Okay, so to get angle W, I'm going to take 180 minus 150. That's going to give me 30 degrees because it's adjacent and forms a straight angle. All right, and then lastly, we know that if this is 30, then Y has to be 30 because of vertical angles. Okay. All right, so number 4, given that L1 is parallel to L2, find the measures of angles A and B. So they're telling you that these are parallel. Okay, so right here. So then we form a sandwich model. Okay, remember for the sandwich model, you have different types of angles. So you have, for example, these two would be corresponding. All right, so that would be corresponding when they're in the same positions. This one's above the bread to the left of the toothpick. Same thing for 2, it's above its bread and to the left of the toothpick. So that's corresponding. Then you have angles like this, which are alternate interior. Then you have angles, and alternate interiors are equal, and so are corresponding. Then you have angles like this, alternate exterior, and those are equal as well. All right, and then and really the last type of angle is same side interior. These are not equal. They're on the same side of the toothpick. We call them same side interior, but they add up to 180. Those are the 4 main ones. Okay. All right, so here find the measures of angles A and B. Well, we know that A and this, A has to be 138 degrees. So the measure of angle A is 138 degrees. and that's because of alternate interior angles. Okay, so that's angle A, and then now if this is 138, then A and B form a straight angle. They're adjacent, so that means B has to be 180 minus that. That's going to give us 42 degrees, okay? And that's they're adjacent. They form a straight angle. Again, do this on a separate sheet of paper just so you can show your work. Don't do it on this paper. I'm just doing it here just so you can see it, but I would suggest doing it on another sheet of paper when you turn it in. Okay, so for part B, now A has to be 38 degrees because A is a corresponding angle. The 38 degrees angle and A are corresponding. Okay, and then let's go ahead and find B. Again, similarly to before, it's 180 minus 38. So 142 degrees. Again, they're adjacent, and they're supplementary. Supplementary is another way of putting it. Is supplementary means the angles add up to 180. Okay, so you could say it forms a straight angle, or they're supplementary. That means the same thing in this case. All right, so number 5. All right, so we got number 5. Find the perimeter, circumference, or perimeter or circumference, and the area of the given figures. Okay. All right, so let's look at A. So A is a circle, and they give you your diameter, right? So the diameter is 17. Okay, so let's do the first part. The first part is to find the circumference. Okay, so the circumference is pi times diameter. So it's pi times 17. So 17 times pi, same thing. And round to the nearest tenth, it says, so 53.4. And what are the units? It's feet. Okay, so 53.4 feet. All right, good. So now we're in part 2, which is find the area. Okay, so the area of a circle is pi r squared. So we need to find the radius. So the diameter is 17, which means that the radius is 17 divided by 2, which is 8.5. So we're going to plug that in for the radius. So 8.5 squared times 8.5 squared. I forgot to include the times. So we got 226.98, but we're going to bump it up to the nearest tenth. So this is going to bump up the 9 to a 0. And so it's going to be 227.0. Okay, 227.0. Because you still want to round it to the nearest tenth, so you got to include the 0.0. All right, that takes care of that one. So let's do part B, part BI. So this is a parallelogram. We want to find the perimeter. And so if that's 16, then this is 16. If that's 18, then this is 18. So we can add the 4 sides, 18 times 2, and then 16 times 2. So we get 36 plus 24 is 60. So we got 60 centimeters. All right, and let's do the area. The area is base times height. The base and the height have to be at a right angle to each other. So this has to be the height, this has to be the base. They're at a right angle, so it's going to be 16 times 4. So times 4 or 14? Times 14. So 224 centimeters squared. And I forgot to put squared here for the area, feet squared. All right, so now let's look at this one. So we got a triangle here. The area of a triangle is 1/2 base times height. But before we do that, let's just do the perimeter. Add the three sides, 15, 20, and 25. Okay, so it's 45 plus 15 is 60. So 60 feet it looks like. All right, and let's do the area is 1/2 base times height. And so here the height has to be 12, the base is 25 because it forms they're a right angle to each other. So we got 1/2, 12 times 25, or 25 times 12. Okay, so we got 1/2 times 25 times 12 is 150 feet squared. All right, so let's look at D, last one here. We got, we're gonna need to add the three sides, 3, 9, 7, and 6. Okay, so we got 12, 19, so we got 25. So 25 feet. And then we'll do the area. So the area of a trapezoid is height divided by 2 times times base 1 plus base 2. Okay, and remember that the base and the height have to be at a right angle to each other. This is a trapezoid because we have two sides that are parallel. Okay, so this is a trapezoid. This is our height that is perpendicular to the bases, right? So that's perpendicular to that. So this is base 1, base 2. So we got 3 and 7 for the bases and 5 for the height. Okay, so we got 5 divided by 12, 3 plus 7. So we get 10, so we get 25 feet squared for the area. All right, so let's look at, by the way, it's a typo. This would say 6, 7. So we'll fix that there, okay? All right, so you fix it all the way down to the rest of the guide. All right, so two angles of a triangle measure 37 and 48 degrees. Find the measure of the third angle, okay? So you just have to remember that the angles in a triangle add up to 180. So we could just figure out the missing angle, okay? So if you add those together, you get 85. And so to get x, you do 180 minus 85, which is 95 degrees. All right, so number 7 here, triangles ABC and DEF are similar. Find the perimeter of triangle ABC. All right, so we want to find the perimeter, and so what we need to do is we need to figure out what this side is, okay? So we're going to set up an equation for that. So remember, since these are similar triangles, we can set up a ratio. So x matches up to 12, and 6 matches up to 9. So we can say x over 12 equals 6 over 9, okay? So x over 12 equals 6 over 9. Oops. All right, and then we got to cross multiply, butterfly method. So we get x times 9 is 9x, 12 times 6 is 72. Then we can divide by 9 on both sides. So you get x equals 8. Okay, so now we know that this is 8, so we can just add the sides together. 6 plus 8 plus 10. So 24 inches is my result. Okay, and then this one, we want to find this one, x. So notice that x matches up with 6 and 4 matches up with 8. Okay, so x over 6 and then 4 over 8. And cross multiply. 8x equals 24 divided by 8, and you get x equals 3. Find your perimeter. You get 3 plus 4 plus 5. So that's going to be 12 centimeters. All right, that's it for that one. Next one, determine whether the two triangles are congruent. If they're congruent, state by which theorem. Remember that there were a few theorems that we've said for congruent triangles. We talked about ASA, we talked about SSS, and we talked about SAS. So those were some of the ones that we did. Okay, those are the 3 ones. All right, so here we got a side that matches up with this side. We got an angle that matches up with this angle, and we got a side here matches up with that side. So it looks like they're congruent by side angle side. All right, here we got an angle, 110. We got a side, 3 miles, that's the same. And we got an angle, same, that's the same, which is 40. So it looks like they're congruent by angle, side, angle. So congruent by ASA. That's it for that one. All right, so find the unknown side of the triangle, round to the nearest tenth of a foot. So this is a right triangle, and so we can use the Pythagorean theorem for this, right? So Pythagorean theorem, a squared plus b squared equals c squared, if you recall. And so, okay, so we're going to do 7 squared plus x squared equals 12 squared. The c has to be the longest side, okay? All right, so 7 times 7 is 49. 12 times 12 is 144. So subtract 49 on both sides. And you get 95. And then to get rid of the squared, you got to take the square root of both sides to cancel out. All right, so you get x equals square root of 95, and we want to round it to the nearest tenth of a foot. All right, 9.7 looks like. Let me double check here. Yeah, so 9.7. Okay. Feet. All right, so number 10, find the volume of the geometric solid. If applicable, round to the nearest tenth. All right, so, okay, so we'll do this one here. We just want to find the volume. So the volume of a rectangular solid is, well, we got length times width times height. Okay, so we got to multiply length times width times height. So 10, 5, 4. So 10 times 5 times 4, that's going to be 80 feet squared, or feet cubed. All right, that takes care of A. So also got B. So B, it looks like a pyramid, a square pyramid. So we got 6, 6, and 8. This is going to be our H, right, the height. And then this is going to be S, which is 6. Okay. All right, so the volume of a pyramid is 1/3 s squared times, in this case, h. And so we got 1/3 times 6 squared times 8. All right, so we're going to do that. So 36 divided by 3. Okay, so 1/3 times 6 times 8. So that's, yeah, so that's 96. Units are centimeters, so 96 centimeters cubed. I guess we can do it over here just for room's sake. All right, so C, we got a cone. So the volume of a cone is 1/3 pi r squared h. This is my h. Now this is my diameter right? The diameter is 12, but then the radius is half of that, okay? So we can plug in the radius. So 1/3 pi times 6 squared times 14. Now it says round to the nearest tenth for that. Okay, so 1/3 times pi is 14. So 527.8 in this case. All right, and that's going to be in feet cubed. All right, so there's that. So let's do D. Now D is a sphere. And they give you the diameter of the sphere. And so the radius has to be 1. And so let's write down the volume, which is 4/3 pi r cubed. We get 4/3 pi times 1 to the third. Do that in calculator. 4.2. Okay, so 4.2 rounds to. And that's in centimeters cubed. Okay, we'll do the last one here for E. E is a cylinder. Looks like they give you the radius is 6. Looks like they give you height is 2. All right, so the volume of the cylinder is pi r squared h. So we get 6 squared times a height of 2. All right, and actually, yeah, and we're going to show you, and we're going to have you round it on the test, so that's okay. 6 squared times 2, so 226.2. All right, and that is in inches cubed. All right, so now we're going to do surface area for number 11. So find the surface area of the solids, if applicable, round to the nearest tenth. All right, so we got another rectangular solid, 14, 10, and 6. Okay, so surface area. The surface area of a rectangular solid is 2 times length times width plus 2 times length times height plus 2 times width times height. Okay, so it's all the combinations of length and width and height, basically. All right, so those are our combinations. So we're going to do 2 times. All right, let's write down what we have. So we got length, width, and height. So we got 14, 10, and 6. All right, so 2 times 14 times 10, 2 times 14 times 6, 2 times 10 times 6. Okay, so we get 568. Okay, so we got 568 inches squared. Now, surface area is an area, so it's going to be in square units. Okay. All right, so now that's it for that one. B, it's a pyramid. So we got 4, 4. So this is S, and then that's my slant height. That's my L, the slant height, because it's at a slant, it's at an angle. Okay. So 4, 4, and 5. Okay. All right, so the surface area of a square pyramid, so a square pyramid is going to be s squared plus 2sl. So we get 4 squared plus 2 times 4 times 5. Okay, so there you go. So you get, so in this case, you should get 56. Meters squared. The units are meters. All right, so now we got a cone. So we got our diameter is 3, so the radius has to be 1.5, and then this right here, that's your slant height, right? It's 9. Okay, so the surface area of a cone. Actually, let me write down what we said. So the radius is half of 3, right? So 3 divided by 2, which is 1.5, and the L is 9. Okay, let's double check that. Okay, good. So then the surface area is pi r squared plus pi rl. We got pi times 1.5 squared plus pi times 1.5 times L, which is 9. So we should get roughly 49.5 feet squared. All right, so let's do D. So D is a sphere. Okay, so again, so the diameter is 3, the radius is half of that. Okay, so the radius is 1.5. Centimeters? Yeah, centimeters. Okay, so then the volume of a, or the surface area of a sphere, not volume, is 4 pi r squared. So it's 4 pi times 1.5 squared. So you should get about 28.3 centimeters squared. Again, we're rounding it to the nearest tenth. All right, and then the last one here for surface area. Again, they give us a diameter. So let's convert that to the radius, cut that in half. And then the height is, looks to be 8. So radius is 4 and height is 8. All right, so the surface area of a sphere is 2 pi r squared plus 2 pi rh. So we got 2 pi times 4 squared plus 2 pi times 4 times 8. All right, so you do that on the calculator, you get about 301.6 centimeters squared. All right, so this one here. So number 12, find the values of sine, cosine, and tangent for the given right triangle. All right, remember it's SOHCAHTOA, right? Okay, so yeah, so now if I look at this angle, then this has to be opposite, and this is the hypotenuse, but we don't have that, right? And so yeah, this is hypotenuse, and then this is adjacent. So all right, so then we have to figure out what the h is, right? So we're going to need to use Pythagorean theorem. All right, so that's 5 and 8. Okay, so use Pythagorean theorem. Was it 5 and 8 or 8 and 5? It doesn't really matter, but I'll go ahead and fix it. All right, we want to get x. Okay, so we're going to use Pythagorean theorem because it's a right triangle. So a squared plus b squared equals c squared. The c is the longest side, which is x. So we get 25 plus 64 equals x squared. So that becomes 80, or 89 is equal to x squared. Take the square root of both sides to get x. And you can't break this any further because 89 might be one of those prime numbers or those numbers that really don't work when you break it apart. So that's okay. We can leave it as square root of 89. Okay, so now we got this is square root of 89, and so now we can do sine, cosine, and tangent. So remember, sine is opposite over hypotenuse. That's why it's called so. So it's going to be 5 over square root of 89. Now, if you put this as an answer, I would accept it. However, I'm going to show you a way to compute that, to simplify that, because usually if you go further on in mathematics, they want you to be able to simplify that. So I'm going to show you how to do that really easily. So what we want to do is we want to get rid of the square root. We never want square roots on the bottom. And so what we're going to do is we're going to multiply by the square root, the same square root that's on the bottom, and we're going to do it on top and bottom. Okay, so we're going to multiply by the same number top and bottom. And so we get 5 square root of 89. We just basically put these together over and then 89. square root of 89 times square root of 89 is just going to cancel out, leaving you with 89. And when you multiply a square root with the same square root, you get the number, basically. All right, so there you go, 5 square root of 89 over 89. All right, so next we have cosine of theta, which is adjacent over hypotenuse. So ca, so we got 8 is adjacent, so 8 over square root of 89. And using that same rule, we can multiply the top and bottom by a square root of 89, and so we get that. And then finally, for tangent, tangent is opposite over adjacent, and so it's going to be 5 over 8. Okay, so there's sine, cosine, and tangent. We're going to call this x, and then we're going to solve it. We can do it over here since we have enough room, I think. So we got a squared plus b squared equals c squared. 20 is the longest side, so it has to go last. All right, so we get x squared plus 100 equals 20 times 20 is 400. So I'm going to subtract 100 on both sides. X squared equals 300. Take the square root. Now this one we can break apart, guys. So we can break apart the square root of 300. So let's do that over here. So 300 is 3 times 100. And then 100 is 10 times 10. And really we can kind of stop there because we already have a pair. You see that? So we have a pair, so we're going to give that pair the boot. And so that pair is going to go outside as a 10. And then we're left with a 3 on the inside. Okay, so we get 10 square root of 3. Okay. All right, so we got 10 square root of 3, so that's what this is. All right, so I do want you to simplify that radical, okay? So practice simplifying radicals because I did teach you how to do that. However, since I didn't really teach you too much how to do this, I'm not necessarily gonna count this wrong or anything like that if you got this, okay? So that's fine. But I do want you to simplify the radicals as much as possible. Okay, so here we go. So now we got, we can do sine, cosine, and tangent. So sine is opposite, and this is opposite. This is hypotenuse, and this is adjacent. So opposite over hypotenuse. So 10 square root of 3 over 20. Now 10 over 20 reduces to a half, right? Because I can divide that. I can divide that by 10 top and bottom. So that reduces to square root of 3 over 2. All right, so now let's do cosine. Cosine is adjacent, which is 10, over hypotenuse, which is 20. And again, similarly, you can reduce that by dividing 10 top and bottom. And then finally, tangent, opposite over adjacent. So opposite over adjacent is 10 square root of 3 over 10, and then notice that the 10s cancel, so leaving you with square root of 3. All right, there you go. So now let's look at last one, or we got 13 and 14, so we got the last two. All right. All right, so number 13, it says find the missing angle, round to the nearest degree. All right, so looking at the same triangle, right? Hold on a second. All right, okay, so let's look at, all right, so here we got, we're trying to find the missing angle. And okay, so like similar, these are the same triangles. So we have opposite and we have adjacent. And so if we want to figure out this, the angle, we have to set up an equation with O and A. That would have to be tangent because of SOHCAHTOA, right? So we're going to set up just the one equation in order to solve for the angle. So we have tangent of theta equals opposite over adjacent, which is equal to 5 over 8. Okay, so that's what we have. Let me just write it over here. Give me some room. Now, in order to get rid of the tangent, I have to do the inverse tangent because that's how we cancel that out. But if whatever I do on one side, I have to cancel, or I have to do it on the other side. So we have theta equals inverse tangent of 5/8. Again, remember the inverse tangent button on their calculator on when you take the test. So when you do the inverse tangent of 5/8, you get 32, so 32.0. We're going to round to the nearest degree, so we're going to round to the nearest whole number. So it's going to be about 32 degrees. Okay, all right, now this one, we have adjacent and we have hypotenuse. So that's going to be SOHCAHTOA, that's cosine. So we have cosine of theta equals adjacent over hypotenuse. And then now to get rid of the cosine, we got to do the cosine inverse. So we do the cosine inverse of 10/20. And you round it, you get 60 degrees. Okay. All right, that takes care of that one. And then the last question, the distance from a plane to a radar station is 200 miles, and the angle of depression is 40 degrees. Find the number of ground miles from a point directly under the plane to the radar station. Round to the nearest tenth of a mile. All right, so the distance from a plane to a radar station. Okay, so we have a radar station here. We have a plane here. And the distance to that is 200 miles. Now the angle of depression is 40 degrees, meaning that we're looking down at the station, and that's a 40-degree angle right there. Okay, and so we have, when we set up the right triangle, we have the height, which we need to find, right? It says find it. Oh, actually, we're not trying to find the height. We're trying to find the number of ground miles from a point directly. So we're trying to find this. We'll call that x, the number of ground miles. Now, if this is 40 degrees, then this is also going to be 40 degrees, okay? Because of alternate interior angles. Remember alternate interior angles when from the sandwich model? Those are equal. All right, so those are 40. So there's our right triangle. So looks like we got hypotenuse, and looks like we got adjacent. So which one's going to be that? This one's going to be the cosine, right? So SOHCAHTOA. So we got cosine of 40 equals, let's do that over here. So cosine of 40 degrees is equal to adjacent over hypotenuse. All right, so then we solve for x. We multiply both sides by 200 to cancel this out. So we get x equals 200 cosine of 40. And so that's going to be around, is it 200 or? Yeah, it's 200 times cosine of 40. Okay, so it's going to be 153. Okay, so 153 point. Let's do it again, sorry. 153.2 miles to the nearest tenth. Alright guys, this is going to do it for the video. Hope you found this useful and informative, and as usual, I'll see you in the next one.